Meant to help the user to better understand the learning process of a neural network, and it uses visualization to show. It shows three plots, and it shows the training of the neural networks. As for the activization function, um, I'm choosing the parameter tang because it squashes the values between -1 and 1, helping the network handle both positive and negative inputs. And as for the learning rate, this value determines how quickly the network updates its weights during training. The smaller values, such as 0.1, makes learning slower but more stable, while a larger value like 0.5 speeds up the training, the learning, but it risks instability. As for the number of training steps, this defines how long the network trains. The more steps allow the network to refine its decision boundary and gradients, but it may overfit if trained for too long. I'll choose the number of steps to be 1,000. And as I said before, the smaller the learning rate, the longer it takes to load, so it'll take a little while to load. Alright, the plot on the left is the hidden space visualization, and this shows how the input data is transformed by the hidden layer. The points represent individual samples, and the yellow, the hyperplane, is the decision boundary in the space. And over time, you'll notice that the network clustering points of the same class move closer together. And as for the input space boundary visualization, the plots in the middle shows the network's classification decisions in the original input space, and the blue and red regions, which will appear in a second, those represent the two classes, and the line between them is the decision boundary. As the training progresses, the boundary becomes more accurate. And as for the gradient visualization, uh, we have the network architecture visualized, and the blue circles represent the neurons, and the purple lines represent the connections. The thickness of each line shows the magnitude of the gradient, indicating which weights are being updated more um, during training. And overall, this tool makes it easier to understand the neural network process, how it processes data, adjusts their weights, and improve classification accuracy over time. And by tweaking the activization, uh, the learning rate, and the number of steps, you could experiment with how these parameters affect the learning process. Thank you.